See? So why am I working out? Actually, there are a lot of benefits of working out. Let's start with a few of them. It gives many benefits to my muscle. For example, it gives strength, endurance, what else? Power maybe. So that is why the reason I create this video today, to talk about muscle. If you already watched my last video, you will know that there are 3 types of muscle, which are a smooth muscle, and then the cardiac muscle, and the last one is our skeletal muscle. Oh man, don't you think that you are too skinny to talk about muscle? You are not even buff. Wait. I suddenly got deja vu. Maybe you should take this. Thank you so much. What is skeletal muscle? Skeletal muscle is all the muscle that help we to do all of this movement, or all the movement that I've done during my workout. So, for your information, skeletal muscle can be divided into 2, which are a slow twitch muscle and fast twitch muscle. So, let's start with the slow twitch first. Slow twitch use oxygen as fuel, and then it fires slowly. It has high endurance. Because it uses energy, it appears more bright red compared to the fast twitch. And then, so this kind of muscle is good for like marathon runner or more activity that need more endurance. Now for the second one, it's basically vice versa, which is the fast twitch muscle. So the fast twitch muscle is it use anaerobic metabolism as fuel, which means that it don't need oxygen. After that, it fires rapidly and give a sudden rapid shot of energy. After that, because it don't have use any lot of oxygen compared to slow twitch muscle, it appear like more pale red, more like pinkish color. So this muscle is good for like sprinter or the athlete that use short period of muscle. You got what I mean? So, let's talk more about muscle. Let's start with its structure. Alright, talking about the structure of muscle, let's start with its most basic functional unit, which is the muscle fiber. Basically, it is the cell of muscle. So, what is the characteristic of muscle fiber? It is long, thin, and cylindrical. Maybe like this pen, if we can imagine. After that, there are a few more stuff inside that muscle fiber. Let's take a look. Alright, now you are wondering, why am I holding a guitar? Well, I am not going to sing you songs, so sorry for disappointing you, but I will use the string of this guitar so that to help you understand about muscle fiber. So the first one that I want to highlight is sarcolemma. What is sarcolemma? Sarcolemma is actually a membrane that wraps along this muscle fiber. For example, like this E string, it contains steel that wrap around it from here to here. So sarcolemma function is to protect the muscle fiber and to send electrical impulses to the muscle. After that, I want to mention about what is named sarcoplasm. Basically, sarcoplasm is the cytoplasm of muscle cell. So it contains protein, glucose, fat, glycogen, oxygen, and iron. Basically, it provides or supply energy to the muscle, so it can contract. Now for the transverse tubule or T-tubule. It is a network of tubule that run across the muscle fiber. Imagine this is our muscle fiber, okay? It runs across the muscle fiber, deep into the muscle fiber. It contains iron, oxygen, and glucose. What is the function of it? So basically, transverse T-tubule, it delivers neuron signal to the muscle so that again it can contract. And the last one that I want to mention is sarcoplasmic reticulum. What is sarcoplasmic reticulum? So the difference between sarcoplasmic reticulum and T-tubule is T-tubule run across the muscle fiber, while the sarcoplasmic reticulum run longitudinally to the muscle fiber. So its function is, or what to mention, it contains Ca2 plus ion, calcium 2 plus ion. What is the function of calcium for this muscle? Again, it is so the muscle can contract. Now after we got the knowledge about all of this stuff, we can start. I can tell you the theory on how muscle fiber contract. There is a theory named sliding filament theory. But first of all, I need to take a shower, so bye bye. Let's get back to the business, which is the sliding filament theory. Okay, so all of this happen inside the muscle cell or the muscle fiber. Inside our muscle fiber, there are a thick filament called myosin, and then there are thin fiber called actin. So along this actin, there are something that called tropomyosin, and then troponin, which something looks like this. Troponin, something like this. So when the sarcolemma transfer the neural signal to the transverse tubule and then to the sarcoplasmic reticulum, it releases Ca2 plus or calcium, ion calcium. So it bind with the troponin and then lift the actin filament and pulling it up. After that, it open the binding site for the head of the myosin. So when it bind, this causing the head to pull like this. So the muscle fiber over here pull to here, and muscle fiber over here pull to here. So what happened is the muscle appear shorter, something like that, right? It's shorter like this. So the muscle contract. So what happened during muscle relax? Basically, it is vice versa, where Ca2 plus do not bind anymore with the troponin, and the head of the myosin did not bind to the actin filament, to the actin, so it relaxed again. Very simple. It is so easy. It just pulling like this, right? And that is all for today's video. Thank you and assalamualaikum. See you guys again in the next video. Mwah!